Algebra 1, this is your work for today. This should match up with your packet for Unit 7, Day 4. And the past couple days we've been working on adding and subtracting rational expressions. And today we're going to be looking at how to multiply or divide rational expressions. And kind of a side note, we'll be for the first time looking at when and how to do some canceling within these rational expressions as well. So if you would, take a minute, look at number 1a and b. These should look really familiar. We've done a lot of work with fractions this year and hoping that you'll be able to handle both of these. So take a minute, pause the video, give these a shot. All right, so let's see if our answers match up. So for number 1, we've got 7/16 times 12/49. And I'm hoping that a lot of you did some pre-canceling, right, before you did the multiplication. Whenever you are multiplying, you can certainly do that. So maybe you noticed that the 7 and the 49 cancel out to be a 1 and a 7, right? 7 goes into 49 7 times. And maybe you did, or maybe you didn't, it's okay. Notice that the other numerator and denominator actually have a common factor as well. So the common factor between 12 and 16 should be 4. Well, 12 divided by 4 is 3. 16 divided by 4 is 4. And finally, I can multiply. And with fractions, remember that you just multiply the numerators times each other and the denominators times each other. So your numerator would be 3. Your denominator would be 28. So 3/28. And I want to show you a slightly different way of looking at this that'll hopefully help us as we move into some more complicated expressions. We're able to see the factors that cancel pretty easily here because we know how the numbers multiply and divide, and so that makes it a little bit easier. Let me propose this to you. What if we rewrote these in a somewhat factored form? What if we wrote 7/4 times 4 for that first fraction? And what if for the second fraction we wrote 3 times 4 over 7 times 7. So if somebody was struggling to see the cancellations we did a second ago, maybe if they wrote it like this, they'd be able to see those cancellations a little bit easier, right? You could see that this 7 cancels with that 7, and this 4 maybe would cancel with that 4. And then just like we did before, we'd multiply, 1 times 3, we'd get 3. 4 times 7, we'd get 28. Same answer, of course, but just a little different way of looking at it. And that's going to be kind of where we head with this here in just a few minutes. We're going to be making sure that we have factors before we think about canceling. Okay, and then B, obviously, is division instead of multiplication. So perhaps you remember that the way to handle this is to copy dot flop. So if I were to do that, I would write -3/20. That's my copy. Dot means you turn the division into multiplication. Flop, it just means do the reciprocal of that second fraction. Okay, so once we've done that, we're back to a real similar looking expression that we had just a minute ago. And I'm going to go ahead and factor this first and try to factor in as smart way as I can. I'm going to say that 3 is prime, so I'm leaving that alone. But 20 I could write as 4 times 5. I know that the 5 in the other numerator is already prime, so I'd write times 5 over, and maybe I'd write 6 as 3 times 2, something like that. So again, just getting it down into its factors make it easier to see cancellations that might happen. You probably can see here that the 5 would cancel with the 5, and this 3 would cancel with this 3. It's a little bit tricky because that was a -3. And so technically when I cancel a -3 over a 3, I end up with a -1 right there instead of just a 1. So when I multiply across here, I multiply my numerators times each other and my denominators times each other. I'm going to get -1 in the numerator, and in the denominator I will get 8. So -1/8 should be the result for 1b. So I hope that makes sense to you. If I could, I'd ask if you had questions right now. And if you do, then for sure you could email me if you'd like. For now, hopefully that makes sense. We're going to use these same kind of ideas here with some more complicated expressions. All right, so for number 2, I've written the word explore here, and so that's what I want you to do. I want you to try to think of the principles we just used in 1A and 1B. And obviously you can see this is more complicated, but let's see if you can use some of the principles. Go as far as you can. I hope you succeed. Hope you can figure it out. But if you end up messing up or something, that's okay right now. We're just, like it says there, we're just exploring this. So take a minute, see if you can use those same ideas we just did, see how far you can get. Pause the video, and once you're ready to see a solution, go ahead and push play, and hopefully you'll be able to make some connections if you haven't already made them. So the first thing I notice here is that we're doing division. So before I get wrapped up in really anything else, I'm going to go ahead and copy.flop. So my first step would be 12 x to the third y to the 8th over 7 times, so there's my copy dot, and my flop will just be the reciprocal of this second fraction. So I'm hoping you got that far for sure, right? Copy dot flop with fractions like this when you're dividing. So now I'm going to go through and see what kind of factors I have. And you could take this pretty far, and I'm going to take it pretty far here just to hopefully help you be as clear as possible. You don't really have to take it this far. If you see the cancellations a little bit easier, you're welcome to not maybe go quite as far as I'm going to go here. So what I'm going to do is I'm going to write 12. I'm just going to write it as 3 times 4. And x cubed, I'm going to write it as x times x times x. And the 7 is just the 7. And then the y's, I'm going to write them all out. So it's going to be 8 of them. 1, 2, 3, 4, 5, 6, 7, 8 of them. So I've written out all the factors here, right? That's really all I can do as far as writing the factors of this out. And like I said, I normally wouldn't go this far, but you're just looking at this perhaps for the first time, and so I want to hopefully help you get as clear as possible. 21 is 7 times 3, 4. I'm just going to leave that as a 4. I know I could write that as a 2 times 2, but I already got my factors of 3 times 4 written up there for the 12. So, and then x to the 4th would be x times itself 4 times, and then y is just y. So I'm going to go through and start canceling. I'm going to cross cancel here. So I notice right away that the 4's cancel, and I see that the 7's cancel. And that's it as far as the numbers go, but there's a bunch of variables that cancel. So these 3 x's would divide out with those 3 x's. And then one of these y's would cancel out with one of those y's. So just like before, when I multiply fractions, I multiply the numerators times each other, and I multiply the denominators times each other. And looking at those denominators, there's not a whole lot left. The 7 canceled, the 4 canceled, 3 of the x's. There's only 1 x left. That's all that's left in the denominator. In the numerator, I notice that I've got a 3 times a 3 left over. 3 times 3 is 9. And I've got no x's left over in the numerator, but I do have 7 of the y's. So it'd be 9 y to the 7th over x. So like I said, I took this a little bit further than I would normally take it as far as all those little details in between. Perhaps that helps. Let me show you a little bit of a shorter way you could have done this. Maybe you did it this way. You could have come up here. You could have just canceled straight off this. Like you could have said the 21 divided by 7 is 3. And you could have noticed that 12 cancels with a 4 to be a 3. And then you could have noticed that this y cancels with one of those, leaving us with y to the 7th. And that all of these 3 x's cancel with 3 of those, leaving you with just an x. And you can see you're going to end up with 9, and then there's still that y to the 7th over x. The reason why you can do that is because this, technically, as it was written right here, technically you could look at that and say that it is factored already, because all the numerators and all the denominators they are already multiplication problems. And so you really didn't have to do all this stuff that I did down here. I just thought I'd do it maybe to clarify what it is we're actually doing. But you might be ready to just jump along this path and go there. If you are, that's totally fine. Okay, so we got one last example to do. And it's right here. Oh, sorry, we have 2 more to do. Here we go. Number 3. So number 3 is another explore, and I want to give you some advice here before I have you pause the video. Notice how this is factored, and notice how the 3 and the 36 are just singular terms, very easily numerically factored if you want. But then also notice that this down here, this denominator, is not factored. So before you go about trying to do any canceling with anything, you need to make sure that everything is factored. And that's really the key. That's where people make mistakes, is they forget to make sure that everything, all the numerators and denominators are all factored prior to doing any canceling. So please do factor that. Let's see if you can get this number 3 here simplified. Okay, so my hint to you before you pause the video was to factor that lower right denominator. And so let's double check and make sure you did that all right. So that lower right denominator should factor as x plus 6 times x minus 4. You would have used the little boxes to do that. Hopefully that makes sense. It's a quadratic, so we usually use those boxes to factor. Okay, so everything is essentially factored at this point. I realize the 36 and the 3 aren't directly factored. I think we can probably do those numerically fairly easily. The key is that that lower right is factored. So when you do that, you probably noticed that the x plus 6 over the x plus 6, that would cancel out to be a 1. This is the right way to do canceling. You must factor. You must have factors before you even think about canceling. And then we'll cancel out the whole factor when we do. Okay, so then the other thing that would cancel here would be the 36 and the 3. The 36 would cancel to be a 12. The 3 would cancel to be a 1. And now I would multiply numerators times each other and denominators times each other. So when I do that, I get x times 12, which we would typically write as 12x. And in the denominator, the only thing left over is x minus 4. Now, for a lot of people, there is going to be some temptation to cancel again. And I want to mention this. What I'm about to show you would be incorrect. You cannot cancel this with this. And the reason is the numerator is 12 times x, and the denominator is x minus 4. So in other words, the x minus 4, that's one whole factor, and you either can cancel the whole factor or you can't cancel any of it. So I can't just pick out little pieces of a factor, like the x or the 4, and cancel those. I got to cancel the entire x minus 4 or none of it. So for that reason, this would be your final, most simplified expression for this, for number 3. All right, and then finally number 4, I want you all to try with a partner. This might be tough if you're just by yourself at your house, so maybe this should be more of a try on your own sort of thing. Please notice it's division. Please notice there's a little bit of factoring to be done, so give it a shot. Go ahead and pause the video and look at the solution in a minute. So, like before, the first thing I'm going to do is recognize that with division, the appropriate procedure is to copy dot flop. So here would be my first step. 5x over x squared minus 12x plus 27. There's my copy. Here's my dot. And then flop would just be the reciprocal of this second fraction. Okay, so step 1 complete, copy dot flop. Now step 2, I need to recognize which of these expressions is factored and which of them is not. So 5 times x, I'm going to call that factored. It's a multiplication problem. 3 times x minus 9, once again, it's a multiplication problem. It's been factored. 10 times x to the 4th, we could factor that a little bit further. We could go into those super detailed steps with x to the 4th being x times itself 4 times and all that stuff. 10 is really 2 times 5. But I'm going to go ahead and call that factored as it currently stands. The one that I really want to focus on is this one down here. That one is obviously not factored because it's a subtraction / addition problem. And so overall, that has not been. So I'm going to try to factor it. So here we go. 5x over, this will factor as x minus 3 times x minus 9. Maybe you use the boxes to do that. Hopefully you arrived at that factoring over there. Now once I've done that factoring and I recognize that everything's been factored, I can now do some cancellations, some canceling. So the first one that jumps out to me is x minus 9 cancels with x minus 9. Notice how I'm not canceling the 9's and the x's. I'm canceling the whole x minus 9. The whole factor cancels out. And if it doesn't, then it doesn't cancel. All right, so then I notice how the 5 is a factor and the 10 is a factor. So the 5 would cancel as a 1 and the 10 would cancel down to be a 2. And then lastly, I recognize that this x is a factor and it would cancel with one of these x's, leaving me with x to the third down there. All right, I'd say at this point it appears nothing else cancels, but let's go ahead and multiply the numerators times each other and the denominators times each other and make sure that that's the case. So in the numerator, it looks like I've got a 1 times a 3. So, of course, 1 times 3 is 3. And down there in the denominator, I've got, it looks like an x minus 3 and a 2x cubed. Looks like that's what I've got. So let's make sure that nothing else cancels. It looks like nothing does. It's going to be really tempting for some of you, maybe all of you, to do this. But please, like before, recognize that the 3 in the denominator is not a whole factor. It's just part of a whole factor. So that factor down there is x minus 3. And so I can't cancel just part of that factor. I've got to cancel the whole thing or none of it. And so because of that, I'm done. There's no more simplification I could do. And so you could rewrite this just a little bit. You wouldn't have to do this, but kind of more of a standard approach as far as a final look would look something like that. But what I have up there would be fine too. So I hope that went well for you. If you have questions, certainly you can email me. If you're feeling like you need some more practice with this, the good news is when I see you next week, we'll be doing another day of work with these types of questions. So hope that went well. Hope that you do enjoy this kind of random, unscheduled day off. Stay safe and look to see you next week sometime.